Hi everyone, welcome back to the channel. In this particular video, I'll be explaining problem B of starters 136. Okay, problem B of div 2. Problem name is sum of modes, and first of all, we will try to understand the problem statement. Then we will see how we can solve this. Okay, guys. So let's begin by reading the problem statement. For a binary string t, f of t is number of modes of t. Okay, f of t means there is a function f in which if you pass a string t, it will give me the number of modes of this particular string. And what are the number of modes? First of all, let's try to understand what is mode. Mode is the most frequent character appearing in the string. Okay, I hope it is clear. Let's suppose the given string is 1 1 0 and 0 and 1. So which one character is appearing the most number of times? That is 1. So 1 will become mode. Now we will ask that, okay, what if ones and zeros are appearing equal number of times? So in this particular case, mode will be 2 because there are two characters which are appearing most number of times. I hope the concept of mode is clear. Since the string is a binary string, here they have mentioned that string is a binary string. So there will be at most 2 mode of any particular substring that you can choose here. Fine. And now let's see what they are asking for. Problem statement says the guys that given a binary string s of length n, compute the value of mode of each particular subarray of given string. Basically, they want us to calculate the mode of each particular subarray of a given string. Okay, how to do that? First of all, let's try to dry run a test case. Let's suppose this is a test case 1 0 1 0 and 1. Or for example, for simplicity, we will take 0 0 1 1. Let's suppose 0 0 1 1. Now in this case, they want us to calculate the mode of each substring of the given string. Okay. First of all, this will be a substring. What is the mode of this? Mode of this will be 1 because there is one character which is appearing most frequent. And now if you talk about the substrings of length 2, then what will happen? This is a substring of length 2. What is the mode of this? 1, because there is one character that is appearing most frequent. Because there is only one character that is appearing most frequent. Okay. Again, this is a substring of length 2. Now what is the mode of this substring? The mode will be 2 because there are two characters which are appearing most frequent. In this manner, you have to calculate the mode of each substring and you have to return that particular answer. Summation of all the modes of each substring. Okay. I hope the problem statement is clear to everyone. Now let's talk about how we can solve this. Guys, see, there is a simple observation here. I am saying that mode will always be 1 or 2. There are only two options. Mode will either be 1 or it will be 2. When it will be 1 and when it will be 2, please mention this. It will be 1 if all the characters are not equal in a given subarray. And if the number of zeros and number of ones are equal in any subarray, then the mode will be 2 because ones and zeros are appearing most frequent simultaneously. Okay, so the mode will be 2. I hope it is clear. Now, how you can solve this? If I try to calculate the mode for each subarray, then it will take order of n cube time. If somehow you will try to manage the calculation of mode of each subarray, still you will take order of n square to iterate over all subarrays. Okay, I hope it is clear. Then we have to find a better algorithm that will be running in less than order of n square. For that, what we will do, there will be total n into n minus 1 by 2 subarrays. Okay, by 2 subarrays. There are total these number of subarrays in a given string. I hope it is clear. Now I have to somehow find that how many number of substrings are there, how many number of subarrays are there in the given string in which number of zeros and number of ones are equal. Okay, number of zeros and number of ones are equal in this. And again, this is a standard problem. This problem which I have explained here, that you have to count the number of subarrays in which all the ones and zeros are equal. This is a standard problem on LeetCode. And talking about how you can solve this to find the number of subarrays, I will talk this in a moment. Before that, let me complete the logic of this approach. Approach will be simple. We will count the total subarrays in which the number of zeros and ones will be equal in order of n time. We will be calculating this in order of n time. Okay. And for all the subarrays, I'm calling this as E. These are the number of subarrays in which all the ones and zeros are equal. Okay. Count of ones and zeros are equal in these number of subarrays E. So for these number of subarrays, my value will be 2. And for the remaining, how many will be remaining? I'm calling this as T. Means total number of subarrays will be n into n minus 1 by 2. And the number of subarrays in which zeros and ones are equal are E. So for the number of sub arrays in which zeros and ones are equal, my mode will be 2, and for the remaining sub arrays means t minus e, my value will be 1. Okay, so 1 multiplied by these number of sub arrays plus 2 multiplied by e will be my answer. I hope it is clear. I hope you are getting the point. So this is the complete solution for this. Now the only thing that is remaining is how to calculate this in order of n time, that how many number of sub arrays are there in which number of ones and zeros are equal. For that I have taken a test case here. Okay, let's suppose here is the test case. Guys, this is a standard problem. Okay, I will explain this in a manner in which most of the people have solved it on the lead code. Even I have also solved that problem using this approach only. First of all, we will try to replace all the zeros with -1, and there is a logic behind this why we are doing so. First of all, we will replace all the zeros with -1. Okay, -1. This one is 1 1, this one will be -1, this one will be -1. Now here is the observation that comes in the picture. Okay, let's take a sub array in which ones and zeros are equal. Let's suppose this is a sub array. Now what do you think, what will be the sum of this array, this sub array? This will always be 0, because ones representing positive 1 and zeros representing minus of 1. So the total summation in which of the sub array in which ones and zeros are equal will always be 0. Now this problem has converted to counting the number of sub arrays having sum equals to 0. We have to perform that in new array which we have formed here. Again, this is a standard problem which can be solved using map. How to solve this? Let's suppose the sum till this point is x, and sum from this point to this point means the prefix sum till this point is x, and sum from this point to this point is also x, means there is a sub array in between which is having a 0 sum. Okay, I hope it is clear. So what you will do, you will maintain a prefix sum, and you will be storing those sums in a map, and x will be stored in the map. And let's suppose here you have reached and you have again found x. Fine. Now what you can say, all the numbers in the map means the number of times x has been appeared previously in my map, those are the number of sub arrays which are having 0 sum. Because let's suppose this is the value of x and here is also x, means there is a sub array in between which is having a 0 sum. Okay, now let's suppose you have moved here till here, and again you have reached the value x. Now there are two values of x which has been stored in the map. Then you can say that for this value there will be two sub arrays which are having 0 sum. Okay, how? First one will be starting from this point and ending at this point. Another one, let me write it in a clear manner. First sub array will start from this point and end at this point. Another sub array will start at this x and start at this x. So number of x which has been stored in the map will represent the number of sub array which is having an ending point at this x and starting point as those number of x. In this manner we can find all the sub arrays which are having 0 sum. Fine. Let me have a dry run for this to have a clear explanation. First of all, you will start from this point. Okay, this one is -1. So you will say that, okay, is -1 present in my map? No, -1 is not present. So we will store -1 in your map. Again, you will move to this point. Prefix sum till this point will be -2. You will ask your map, is -2 is already found somewhere in previously? Map will say no, there is no -2 found in the previous path you have traversed. So we'll say, okay, store this -2 if in forward direction. If somewhere I get -2, then I will say that, okay, starting point is this and ending point will be this. Now you will move to next index, and prefix sum till this point is -1. You will ask your map, is there a -1 found previously? Map will say yes, -1 has been found previously, and there are total one number of -1 that has been found. So we'll say that, okay, there is one sub array that will be starting at this -1 and ending at this -1. And what is represented by this, guys? Let me explain that also. This is saying that your sum till this point was -1. Okay, and after reaching this point again you have got a -1, means there is a sub array in between which is having a 0 sum. As you can see here that this is a sub array which is having a 0 sum, and 0 means number of zeros and ones are equal in this sub array. Okay, this is represented by this, means there is a one starting point and one ending point for this. So answer will be 1. Again you will move to next index and you will say, what is the next sum that I am getting? -2. Is there a -2 that I have previously seen? Yes, you have seen a -2. Map will say you have seen a -2, and you will ask how many -2s I have seen previously. This will say 1. So we will add 1 to your answer. And what does it represents? It represents that till here your sum was -2, and after reaching this point your sum is again -2, means there is a sub array in between where all the elements are 0. Okay, now as you can see here, this is here again a sub array is found where we are having a zero sum, means number of ones and zeros are equal. In this manner you will traverse through all the elements and you will find in order of n log n time. And why I'm saying n log n? Because inserting into map will take log n time. Okay, log of n time. So you will find the number of subarrays which is having equal number of zeros and ones in order of n log n time. And after this logic has been explained here. Fine. So yeah, this was all about problem B.